Hello friends. Now in this session we are going to discuss about analysis of a long transmission line. We can also call this as rigorous method, that is a rigorous method of analysis of transmission line. So to understand about a long transmission line, just go for the previous video of my YouTube channel. So here this figure, that is this circuit diagram which shows long transmission line. So here we have to understand the circuit diagram first and the parameters whatever and all will be using in the circuit diagram. So this is having a one phase and neutral connection. So this is one phase and neutral connection. So as well, let us discuss about the notations what and all will be using. So consider a small element in the line of length dx. Consider a small length of element of length will be having dx. This will be placed at a distance. This will be placed at a distance x from receiving end. Placed at a distance x from receiving end. So let us see. So here z is nothing but small z is nothing but series impedance of the line per unit length. Similarly, small y is nothing but shunt admittance of the line per unit length, and capital V is nothing but, so this capital V is nothing but voltage at the end of elements where it is placed end of elements towards receiving end or else towards load. Similarly, V plus dV is nothing but voltage at the end of element towards sending end, and I plus di is nothing but current entering to the element dx. So the dotted line is nothing but the element, so current entering to this element is nothing but I plus di. Similarly, current leaving from the element is nothing but I. Okay, then so just look at the observation here. So Z into dx is nothing but series impedance where it has R plus jXL. Similarly, Y into dx is nothing but a shunt admittance. So that you have to write a small change in voltage dV is given by Z into dx plus Z into dx into I. So that I into Z into dx is nothing but dV. I into Z dx is nothing but dV, only dV, only dV. So next, coming for the analysis. So consider a small length as we discussed. Z is nothing but a series impedance of line per unit length. Similarly, Y is a shunt admittance and V is voltage at the end of element towards receiving end, and V plus dV is voltage at the end of elements towards sending end. Similarly, I plus di is current entering the element dx, and capital I is nothing but current leaving the element dx. Small change in dx, as I told, z into dx is nothing but series impedance, y into dx is nothing but shunt admittance. So we can write dv as I into z into dx. So I can rewrite this as dv by dx. I'll send dx here so that dv by dx equals to the rest of the simplification. So I'll send this dx to the left hand side so that dv by dx is nothing but I into zx. Give this as equation number 1. Now current entering to the element. So here the current entering to the element is nothing but small change in dx. So the current entering to the element is I plus di, whereas current leaving from the element is I. The difference between the current flows to the shunt admittance of the element, that is small change in current di, So this di is given by v into y dx, whereas dv is given by I into series impedance I into z dx, so that this v is given by, sorry, the change in current di is given by v into y dx, v into y dx. So analysis, I'll go for the analysis, so that the di I can write as current through the shunt admittance is given by v into y dx from the circuit, so that I can write here di by dx equals to v into I. Give this as equation number 2. So I'll go for the next slide. So for this, what we are doing, differentiating the equation 1, that is the equation 1 is dv by dx equals to I into z. Differentiate this expression with respect to x. So what we are getting by differentiating this dv by dx equals to I into z, differentiation of dv by dx with respect to x is nothing but d square v by dx square equals to, with respect to x we are doing, so that we can write here with respect to x, z into di by dx, z into di by dx, plus the I u into v, the differentiation of u into v, the same formula you have to apply as you guys studied in mathematics, so that I can write here z into di by dx plus, so here di by dx is nothing but v into y from the expression 2, that is from the equation 2, so that I can write here it as z into v into y. So rewrite this as yz into v. Differentiation of dv by dx with respect to x, we can get I in, sorry, z into di by dx, whereas z here is constant, we will be differentiating I with respect to x, so that we can get z into di by dx. Di by dx is nothing but v into y, so that z into vy. So rewrite this expression as d square v by dx square equals to y into z into v. Similarly, for this particular expression 3, for the particular equation 3, we'll be getting the differential equation. So here I am not going to go in deep for the differential equation. So I think you guys will be knowing about the differential equation. By solving this expression 3, we can get the differential equation v equals to k1 into cos h of x root yz plus k2 into sin h x root yz. Give this as equation number 4. And the next is similarly differentiating expression 4. So once we'll be getting this differential equation from equation 3, differentiate this with respect to x again. Differentiate equation 4 with respect to x. We can get dv by dx equals to k1 is constant, so that, so differentiation of cos hx is nothing but sin hx, so that here you can write as differentiation of cos h x root yz is nothing but square root of y into z sin x root yz plus k2 is constant, so sin hx is nothing but cos hx, so that with respect to x, so that root yz into cos h into x root yz. But we know that dv by dx is nothing but I into z from equation 1. Substitute that in case instead of dv by dx, I will write here I into z is given by k1 into square root of yz sin h x root yz plus k2 into zy cos h x root yz. So I want to get current I, so that I can write here it as square root of yz, the simplification I'll be sending this z to the right hand side, so that I is given by square root of yz. Simplification, what we are going to do is here yz is a constant, sorry, not constant, it's a common, so that I can write here it as a k1 into sine h root xyz hx into root yz plus k2 into cos hx into root yz into z will be sending it to the right side, so z I can read it as root z into root z. Root z and root z will get cancelled, so the rest part is only root z in denominator, so that you can get square root of y into z on the RHS side. Give this as equation number 5. The next is equation 4 and 5. Give the expression for v and I in form of unknown constants. Look at the equation number 4 and 5. Both are having the unknown constants, say it as k1 and k2. So this k1 and k2 is nothing but unknown constants. The values of k1 and k2 can be found by applying the end conditions as under. So with the help of the condition, we can get the value of k1 and k2. So what I'll be going to apply the condition is that at x equals to 0, v equals to vr and I equals to ir. So I'll substitute this condition to the equation number 4. So here the equation 4 is v equals to k1 into cos h x root yz plus k2 sin h x root yz. Here I'll put x equals to 0 and v equals to vr. So by substituting the value of x as 0, this is cos h 0 and this is a sin h 0, so that I can get here the expression as vr equals to v equals to vr k1 into cos h0 plus k2 into sin h0. Cos h0 is nothing but 1, so that vr equals to k1. So the value of k1 is vr. Similarly, to get the value of k2, what we are going to do is, will be again similarly we'll be putting x equals to 0, v equals to vr and I equals to ir in the expression 5. So here x is 0, so that sin has 0, cos has 0 and I equals to ir, so that I can write as I equals to ir equals to square root of y divided by z. Cos has 0 is nothing but 1, so that into k can get here. So sin h0 is 0, cos h0 is 1, so that ir equals to square root of yz into k2. So with the help of this, you can write the value of k2 as square root of z divided by y into ir. So now we are getting the unknown terms. Just substitute in the equation 4 and 5. We are getting the expression as the substituting the value of k1 and k2 in the equation 4 and 5, we can get the final expression. See here, the equation 4 is v equals to k1 cos h into x root yz plus k2 into sin h root x into yz. Here we can get the value of k1 as vr, so that substitute wherever there is a k1 vr, wherever there is a k1 vr for the equation 4, so that wherever there is a k2, there you substitute square root of z divided by y into ir, so that you can get the expression. These are the expressions we'll be getting with the help of unknown terms k1 and k2. Similarly, the sending end voltage and sending end currents are obtained by giving the values, by substituting the value x equals to length L in the above expression. So here what we'll be doing, SV, instead of writing V, I'll write Vs, whereas I'll substitute wherever there's a x, I'll substitute the value of x as L. I'll substitute the value of x as L, so that I can get cos HL sin HL. Wherever there is a x, I'll substitute x as L, so that here, so this L into square root of yz, we can write it as, I'll just write this L, instead of writing L, I'll write this as a square root of L into square root of L. So that I'll multiply this, so that instead of, if you multiply square root of L into square root of L with respect into the square root of y into z, you can get square root of L into y into square root of L into z. So here this I can rewrite as L into y is nothing but admittance y, that is a total shunt admittance. L into y is nothing but total shunt admittance. L into z is nothing but total series impedance, so that I can rewrite this as y into z. Capital Y is nothing but total shunt admittance of the line. Similarly, capital Z is nothing but total series impedance of the line. So similarly, how can you write for square root of y divided by z? So I can rewrite this as again square root of y into L divided by square root of z into L. I can get square root of y divided by z. So what we are going to do, will be substituting the value of total shunt admittance and total series impedance of the line, so that I can get Vs equals to Vr cos square root of yz into L is nothing but square root of yz. Similarly, square root of L into yz is nothing but square root of y into z. So square root of z by y I can write as capital Z by y instead of total. So this is the expression for sending end voltage and sending end current of the transmission line. So these expressions will help you to solve the problems, that is to expand hyperbolic sine and cosine in terms of their power series. Cos h root y z we can write as mathematical expression. I hope you guys know about this. You can write it as 1 plus zy divided by 2 plus z square y square divided by 24 and so on till the end. Similarly, sin h root yz plus yz to the power 3 by 2 divided by 6 plus and go and so on. Generalized circuit constants will discuss in next section. Thank you one and all.